Hello guys, good morning. Welcome back to our YouTube channel Maths Tutorial by Dibesh. In our previous video, we have started Determinant chapter. We learn about basics of determinant and some symbols. Today we'll study about determinant properties of determinant. So first, Theorem 1. If all the rows of determinant are converted into corresponding column, then the value of determinant remains same. So if we apply Ri to Ci, means corresponding row changes to corresponding column. If A is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3, then by doing Ri to Ci, A dash is equal to row changes to column. A1 B1 C1 A1 B1 C1 A2 B2 C2. Second row changes to second column, that is A2 B2 C2. Third row changes to third column, that is A3 B3 C3 A3 B3 C3. So clearly here the value of determinant does not change, that is A is equal to A dash. Let's understand by some example. A If A is equal to 1 2 3 minus 3 4 minus 1 2 1 4, then determinant A is equal to 1 4 4s are 16 minus 1, that is plus 1, minus 2 minus 3 into 4, that is minus 12, minus 2 into minus 1, that is plus 2, 3 minus 3 into 1 minus 3, minus 2 into 4 minus 8. So we'll get 16 plus 1, that is 17, minus 2 into minus 2 plus 2, that is minus 10, into 2 minus 20, minus 10 into minus 2, that is plus 20, minus 3 minus 8 minus 11, into 3 minus 33. So 17 minus 20, that is 37, minus 33, that is 4. Then applying Ri to Ci. Ri to Ci means row changes to column, that is 1 2 3 1 2 3 minus 3 4 minus 1 minus 3 4 minus 1 2 1 4 2 1 4. Now again finding determinant A dash, will get 1 4 4s are 16 minus 1, that is plus 1. Already minus sign, that is minus plus 3, 2 4s are 8 minus 3 into 1 plus 2 minus 2 minus 3 4s are 12. So 16 plus 1 17 and 1 is 17. 8 minus 3 5, 3 is 15. Then minus 2 into minus 12, that is minus 14, 2 is minus 28. So 17 plus 15, that is 32, minus 28, that is 4. So clearly if you apply Ri to Ci, then value of determinant does not change. Next, theorem 2. If two rows or column of determinant are interchanged, then the value of new determinant is additive inverse of given determinant. If you apply Rij or Cij, if D is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3, applying R1 3, that is R1 changes to R3, R1 changes to R3. So R3 comes here, R1 comes here. So you'll get A3 B3 C3 A2 B2 C2 A1 B1 C1. Let's understand by some example. 1 2 3 minus 3 4 minus 1 2 1 4. If you find determinant D is equal to 1 into 4 4s are 16 minus 1, that is plus 1, minus 2 minus 3 into 4 minus 12, 2 into minus 1 minus 2, that is plus 2. So plus 3 minus 3 into 1 minus 3 minus 2 into 4 minus 8. So 16 plus 1 17, minus 12 plus 2, that is minus 10, into minus 2, that is plus 20, minus 11 into 3 minus 33. You'll get answer 4. Now applying R1 3. R1 3 means row 1 changes to row 3, that is 1 2 3 changes to here, and this comes here. That is 2 1 4, 2 1 4 minus 3 4 minus 1 minus 3 4 minus 1 1 2 3 1 2 3. Now determinant of d dash is equal to 2 multi multiplied with 4 into 3 12 minus minus plus, that is 2 ones are 2 minus 1 minus 3 threes are minus 3 into 3 minus 9 minus minus plus 1 into 1 1 plus 4 minus 3 into 2 minus 6 minus 4 into 1 minus 4. So we'll get final answer, that is minus 4. So clearly if you apply Rij or Cij, then answer will be additive inverse of first. So d dash is equal to minus d. Next theorem, third, the value of determinant gets multiplied by k if every entity in any of its row is multiplied by k, where k not equal to 0. If rik or cik, then d dash is equal to k times of d. Let's clear by example. If d is equal to 3 2 1 4 5 6 1 minus 3 2, applying c1 3 means 3 multiplied with c1. C1 is first row, first column, that is 3 3s are 9, 3 4s are 12, 3 1s are 3, and others remains as it is, that is 2 1 5 6 minus 3 2 minus 3 2. Now find determinant of d, that is 3 5 into 2, that is 10, minus 3 into 6, that is minus 18, it becomes plus 18. Next, minus 2, 4 2s are 8, minus 1 into 6 6, plus 1, 4 into 3 minus 3, that is minus 12, minus 1 into 5 5. So 18 plus 10 28, 28 3s are 84, minus 8 minus 6, that is 2 to 4 minus 4, minus 12 minus 5, that is minus 17. So 84 minus 4, that is 80 minus 17, 80 minus 17, we'll get 63. Now d dash is equal to 9 5 2s are 10 minus 18, that is plus 18, minus 2 12 2s are 24, minus 3 6 are 18, plus 1 12 3s are minus 36, minus 3 5s are 15. So 28 into 9, that is 252, minus 24 minus 18, that is 6, into 2, that is minus 12, minus 36 minus 15, that is minus 51. So after final solving, you'll get 189, which is 3 times of 63. So clearly you can write d dash is equal to 3 times of d. So hence k times of a1, k times of b1, k times of c1, a2, b2, c2, a3, b3, c3 is equal to, you can take common k, that is k times of a1, b1, c1, a2, b2, c2, a3, b3, c3. Next theorem 4, this is important. If a1 plus d1, b1 plus e1, c1 plus f1, a2, b2, c2, a3, b3, c3, then you can write this as a1, b1, c1, a1, b1, c1, a2, b2, c2, a3, b3, c3 plus d1, E1 F1 D1 E1 F1 A2 B2 C2 A3 B3 C3 A2 B2 C2 A3 B3 C3. Remember that if there is minus, this sign will be minus. If there also A2 plus D2 B2 plus E2 C2 plus E2, then we cannot write A1 A2 A3 B1 B2 B3 C1 C2 C3 plus D1 E1 F1 D1 E1 F1 D2 E2 F2 D2 E2 F2 A3 B3 C3. We cannot write that. It is only for one row or one column. Remember that. Theorem 5. If the corresponding entries in any two rows or column are identical, then the value of determinant is 0. If D is equal to A1 B1 A1 A2 B2 A2 A3 B3 A3. Look at here. First column and third column are same. If there is two row or two column are same, then answer will be 0. Theorem 6. The value of a determinant does not change if any of its row or column is multiplied by by non-zero real number k, non-zero real number k, and added to another row or column. So R21k, that is R1 R21k, that is R1 is equal to R1 plus k times of R2, k times of R2. If we apply this, then value does not change. See how D is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3, and D dash is equal to R1 plus k times of R2. R1 means A1 plus k times of A2, A1 plus k times of A2, B1 plus k times of B2, C1 plus k times of C2, and A2 P2 C2, A2 B2 C2, A3 B3 C3. Now applying fourth theorem, this one, you can write this as D dash is equal to A1 B1 C1 A1 B1 C1 A2 B2 C2 A3 B3 C3 plus K A2 K B2 K C2 K A2 K B2 K C2 A2 B2 C2 A3 B3 C3. Now again applying theorem 3, that is you can take K as common, that is K A2 B2 C2 A2 B2 C2 A3 B3 C3. Now here you can apply theorem number 5, that is both the rows are same, so answer will be 0. So D dash will be only this, that is A1 B1 C1 A2 B2 C2 A3 B3 C3. So clearly D dash is equal to D. This is our property segment. So thanks for watching my video. If there is any feedback or comment or any doubt, then do let me know in the comment box. Thank you.